start with being a data analyst, start with Python, start with few machine learning POC projects, and there's a whole bunch of use cases that are out there on the internet itself. My name is Krishna Yogi, and like you introduced, I've got about 10 plus years of experience in data science. I started, I did my undergrad from IIT and then did my master's from NUS Singapore. After that, I started working with an investment bank you must have heard of in the news called Credit Suisse. We just got acquired by UPS as a quant analyst, right? And after that, I slowly moved up the ladders, started working as a data analyst, and I guess the last 5 plus years I've been working as a data scientist per se. Um, I've always been, let's say, playing with data, you know, and there are a lot of new things that keep evolving over time. And now we've moved on to this really exciting phase of deep learning, which I think is going to be an incredibly powerful technology in the future, as we see, right? Uh, that on that keeping that on one track, I have a lot of interest in systems design as well. I've done a couple of startups myself, and I've been a CTO for those startups. So I understand how you will basically take different systems and services that are provided on, let's say, a cloud like AWS, and stitch them together to get a result out of it, right? Essentially, systems design is more like tuning a car or something, right? Like you tune the car to improve the performance or improve the torque, etc. Systems design you can think is something like that. Like say you have a goal in mind, you want to go ahead and do it, and that's has been my passion, you can say. Now I'm fortunate enough to be in a position where I'm able to combine both my skill and passion, and I'm very excited about the future of AML solution architecture. If you go back to like the dot-com era, 20 years back, right? We didn't have so many technology startups and companies, etc. Primarily, the wave of this whole software companies, etc., started because of software, right? And essentially, moving data from point A to point B. That is at the core of it. You're basically moving data from point A to point B, and you're generating data, right? So somebody does a click on your website with the data that is captured in the backend, and you're moving that data from A to B, right? Now, this is what is called as deterministic software, right? Wherein you have a very high clarity on what the data is, what the outcome is. So if you put an A here, you got to expect an A at the end of the journey of that, right? And that's how software typically runs. That's deterministic. So essentially, this is a very high-paying job, right? So basically, what solution architects would do is they design the software system to meet the business objectives, right? Like I said, they fine-tune the system, they make sure they're utilizing the resources correctly, etc., to deliver the goal, the business goal, which is basically a software-driven system, right? And that's solution architect. That's the job role of solution architect. Now, an ML solution architect or ML architect is essentially putting an additional layer on top of the software stack, right? So let's say you have a system, like let's say Ola or Uber, right? So you go and take your app and then you say, I'm here, serve me a, car, right? Like serve me a taxi. Now, once you do that, what happens is this data gets transmitted, goes to servers, and then they actually have, they then have to see who are the nearby taxis, and they give you an estimate. Like, they give you an estimate saying, hey, it's going to be 3 minutes before you get this taxi to your door or whatever, right? Now, that's not deterministic. That's probabilistic. Okay. So because they're actually calculating all this number in the backend using some complex algorithms. That is machine learning, right? That is basically machine learning being used in real time. Okay. Now, how do you design a system like that? Because it's not just moving data from A to B or collecting data, right? You have to make predictions. You have to make predictions in real time. You have to serve them efficiently. You have to make sure there's no wacky predictions happening, because ultimately machine learning is probabilistic. So there's no definitive answer for anything, right? So this additional layer of dealing with this additional layer of complexity is the job of ML solution architect. The last 20 years have been the we can call it a decade of software companies, right? Because there's a new idea. Somebody thinks, hey, prior to Uber, we were all hailing taxis with bare hand, right? We'd stand in the road and then hail a taxi or an auto. But now, you can sit it in the comfort of your home and then click a couple of buttons and get that, right? Now that's a revolutionary idea. So there were many such revolutionary ideas, like e-commerce or whatnot. But I think we have now come to a phase wherein those revolutionary ideas have kind of saturated, right? Because if you look at the last 5 years, was there a real unicorn which is purely based on tech? Probably not, right? That's because the ideas have been kind of exhausted, I would say. The big ideas, there are small ideas out there. Now, what is happening is, in the course of execution of these software ideas, the companies have amassed enormous amounts of data, right? And we now have a whole bunch of new sensors, smartphones, and whatnot. So as you've seen in the news or read somewhere, there's an explosion of data. The data is continuously increasing, right? Now, what is happening as a result of that is the skills to crunch this data and make sense out of it or build applications on top of it is going to be the new software. Like what happened 20 years back. For the next 10, 20 years, it's going to be the boom era would be the AIML, right? And we are seeing a lot of applications come out of it already. And this is how it's good. This will continue and keep progressing. And in the near future, we would be seeing self-driving cars. There's a lot of trial runs happening in US and Europe already. So imagine something like that, right? That's going to completely revolutionize the way transportation works, and not just that, there will be many more applications of computer vision, NLP, like what we see in ChatGPT, etc., right? So I would say the next 10 years or 15 years or 20 years is going to be these unicorns that we born in the AI ML space. So you have to understand that first, and then have a passion and motivation to pursue in this industry. So I think the number one misconception that people who are not in AI is that whenever they look at an application of AI, right, they think it's magic. Yeah. So I'm sure you've tried ChatGPT or DALL-E or something, and it gives you this incredibly humanistic result, right? The reality is that there's obviously no magic. It's just mathematics behind it, right? There's a lot of data, there's a lot of math, there's a lot of predictions, and a lot of times things go wrong, right? So, in ChatGPT itself, if you ask a question, a lot of times the answer comes out very confident, but the answer is pretty wrong, right?
Yes.
Unfortunately, the way AI systems work is that, like I said, they are probabilistic, so they work till some point of accuracy, but they have a definite failure, okay? So there's never going to be 100% accurate, which means, you can't take them too seriously, okay? But, just because you can't take them too seriously doesn't mean you can't use them, right? They definitely have use cases. For example, I think in the next 5 years or so, we're going to see full-on self-driving in the US at least, okay? Which means it's an incredible achievement for a machine to do what a human system can do. So driving is an incredibly complicated skill that we take for granted, right? That's because our brains are incredibly complicated, okay? So they're so sophisticated that they're able to calculate this moving objects and identify the objects, etc., which all happens in a split second in a brain. But the fact that self-driving systems can do that, that's just amazing. It's going to be the next big economic productivity leap that we're going to see in the world, right? Imagine you don't have to drive; you just press a button, go to work. That's just going to change the way people are going to do work and live life, right? So it's an incredible achievement. But then, it's not 100%. It's not going to be 100% accurate. There's no magic per se. It's understanding, it's learning, it's trying, it's getting it wrong, and then finally mitigating those mistakes, and constantly mitigating those mistakes. I think that's it. So ultimately, what I do is basically constantly mitigate those mistakes. So if I know something is went wrong, then we try to figure out a solution to bring that error. Right? That's the job basically. So there's no magic per se, but it's more of continuous learning and understanding where things are going.